Good day, everyone, and welcome to Fly-In Solutions, adding value with drone surveying and sensing. My name's Sue. I'm your event manager. During the presentation, your lines will remain on listen only. If you need assistance, just key *0 and an operator will be happy to assist you. You may submit questions throughout the WebEx by clicking on the Q&A section, typing your question and clicking Send to all panelists. These will be addressed in the Q&A session at the end. I'd like to advise all parties the conference is being recorded, and now I'd like to hand over to Robert Windell. Please go ahead, Robert.
Tim, I think actually you're going to start out, aren't you?
Yes, apologies, I was muted. So welcome everyone to our webinar today, Adding Value with Drone Surveying and Sensing, given by Robert Windell and Jeffrey Hong, both Parsons employees. And I'm going to jump to your intros. So our presenters today are Jeffrey Hong. He's a construction engineer with 8 years of experience working with small unmanned aircraft, and he's one of our lead pilots here at Parsons for our UAS program. And we also have Robert Windell, who is a multidisciplinary geologist and geophysicist with 8 years of experience in the mining, manufacturing, and environmental industries. And he has a lot of experience with the post-processing of drone-derived data.
All right, thanks, Tim. This is Jeffrey. It's customary for Parsons to start all of our meetings and conferences with a core value. Today's core value will be on safety. Specifically, since we're discussing flying objects to start with, we figured we'd discuss how to address the unexpected flying creatures that come into your home or office. Next slide, please. Awesome, thank you. So occasionally during the summertime, we'll find young bats and birds that make their way into offices through openings. When this happens, oftentimes we don't know what to do. Within our professions, we have procedures set in place for when different things occur. But when these kind of unexpected actions come in place, the first thing we have to do during these encounters is think about safety. So safety of yourself, safety of others, even safety for the animal itself. So one of the first things to note when these animals come in and they're coming into your building and they're confused. So one of the most simple things you can do is leave the area and isolate the area where the animal had come through, and the animal will eventually find itself out, find its own way out. There's no need to go chase after it as long as the opening is open. Second step, if that doesn't work, is to call someone, calling a professional in animal control who can come and help you resolve this issue. The third option is to do capture and release. So in this case of this bat that entered this particular building, it was sleeping during the day, and in the evenings it would become active, but that was when all the doors to the building were closed and the bat could not find its way out. Fortunately, I found it resting underneath the stairwell, and we were able to put on proper PPE, so long sleeve shirt, gloves, safety glasses, and grab a safety vest, and we were able to scoop the bat out and bring it outside. So just a quick safety, this is just a quick safety moment on all the unexpected things that you might find in a workplace, which are actually more common than you think. All right, so let's get on to the drone side. So drones is a common term that we hear here in the industry. You hear drones, and then the more formal term is unmanned aircraft system. So the drone itself is part of the unmanned aircraft. It is the object that's actually flying in the air. The UAS, however, the unmanned aircraft system, is an all-encompassing term. It includes not only the drone itself, but includes the communications and control systems involved in it, including your transmitters, being able to feed video, telemetry, takeoff and landing systems. And all this together is called the drone. So at Parsons, we have we've identified different kinds of applications for unmanned aircraft. These are some common areas that we have been asked for by different clients and also internally in-house. So we've broken down these categories into 5 broad categories of asset and inventory management, maintenance inspections, construction monitoring, rapid emergency response, and operational research. Today we'll be going and diving into some of these different applications within each one and showing what Parsons has done with unmanned aircraft in these specific areas. So the program approach is something I want to touch on before we start discussing how Parsons does aircraft operations. Parsons has been doing small unmanned aircraft system work, so these drones under 55 pounds since 2016. And we have large success doing it in the United States as well as Canada. So in order to grow a program and make it professional, it needs a few things. Number one, you need the resources. You need resources with manpower, with the knowledge, the understanding of how everything fits into the Civil Aviation Authority's operational space. So you need to have resources to understanding. You need to have funding. Any program that needs to be able to take off needs adequate initial funding to make its way off the ground, to get the equipment, get the right people, get all of the needs covered, the basic essential needs covered before the program can start growing. It needs involvement from higher management. Management needs to be on board. They have to be able to see the value in order to properly invest in the right areas. And on top of all this, everything comes down to a safety-based approach. Oftentimes with new innovative technology, having any sort of major incident will cause a program will cripple a program. So Parsons has done our program through a safety-based approach. These kind of programs need a solid backbone. So Parsons has our unmanned aircraft program. All of our operational aspects can be nailed down or can be traced back to our flight operations manual. This document is an aviation-based program developed by both the manned and unmanned pilots at Parsons. It comes up with our industry best practices. So everything ranging from mission planning to battery maintenance to unmanned aircraft maintenance to doing everyday procedures, tracking flights, tracking the weather, doing currency requirements, making sure that everything is good to go within the program, including the structure of how the program is broken down. So Parsons has a program structure where the UAS governance board is composed of manned, unmanned pilots as well as management, where they determine the strategic direction of which way our UAS development should go. Corporate safety is tied into there to make sure that all the operations follow Parsons risk management best practices to where we aren't adding undue risk for any of our more innovative solutions that we might be delivering. Under the governance board is the Parsons designated instructor pilots. These people are the ones that are responsible for training all our new pilots coming in. And then our pilots in command are the people that are actually operating the sticks on the aircraft. So everything is built in this way because it follows best practices for a safety management system. All our pilots in command understand good aeronautical decision making. So on the next slide, pilots in command. So flight crew organization. On any sort of Parsons UAS operation, you will find that no matter the person's position, if whether or not they're a vice president, an engineer, project manager, GIS specialist, any of our marketing folks, whoever is flying the drone, they are called the pilot in command. They understand the program structure to where they have the final no-go or go decision on operating the aircraft. Under them is the visual observers who spot for them, who observe the airspace, make sure there's no obstacles in the way, both for manned, unmanned, or other flying objects or any sort of power line, things of that nature. And then additional flight crew and observers are everyone else that's responsible for, or that are part of the UAS operation, but not necessarily part of the flight crew. All right, so how do we do this? So, or why do we do this, rather? So, as you know, over in the United States, the FAA's Part 107 pilot exam is a knowledge-based exam. What that means is there's not the practical hands-on portion. So, although pilots will be able to understand basic things of airspace and the regulations for flying unmanned aircraft, going on hands-on is not a requirement. So, to make our pilots ready for any operation, we run all our pilots through our standard training development program to teach pilots about these best practices on how to actually man aircraft in the field. So to do this, Parsons has a few kinds of training and development activities. So our Parsons designated instructor pilots, as well as the pilots in command, go through different kinds of industry conferences and webinars to learn about the latest technology, to keep up with what's going on. FAA often puts on wonderful webinars that are knowledge-based for anyone to attend. Parsons follows closely on the different public safety happenings that are going on. Public safety, as we know, is one of the adopters of UAS that has fully adopted UAS into their operations. If you've seen now, many departments across both fire departments, police departments, emergency management agencies are all operating the latest and greatest UAS for their public safety missions. Learning from them, seeing what works for them has been a huge help to Parsons in developing our program. In-house, Parsons holds different kinds of trainings, with the basic remote pilot training for our pilots, visual observer training for visual observers, trainings on navigating complex airspace. Oftentimes, Parsons is operating in different areas that require coordination not only with the FAA or the local air traffic control tower, but also folks within the DoD, Department of Homeland Security, different kinds of national parks and different agencies in order to be able to coordinate our flight operations in these complex areas. One topic that we want to dive in on today is photogrammetry. Parsons has found that photogrammetry deliverables is a consistent ask by both clients and in-house. So Robert's going to discuss what even is photogrammetry and how has Parsons developed innovative solutions within photogrammetry to deliver to our clients.
Thanks, Jeffrey. So for those of you who don't know, photogrammetry is basically the science of taking measurements from multiple photographs to create a 3D view of that object. Just like our eyes take two different images and combine them to give us 3D vision, photogrammetry does the same thing, but with multiple photographs. So you can see in this photograph a picture of a shrubbery, and you can see that there are 3 focal points. Each of these focal points, if we know their position and we know the position of the pixel in the photograph, we can trace a ray from our focal point through that object, and it will show up where that object resides in physical space. If you do that with more than one focal point, you get greater reliability or greater accuracy in your measurements of that object. So this is sort of a real-world example from one of our sites in Utah where we created a digital model. And you can see I've selected a single point here on the photo, and these are all the images that we took in the air. So this single point might have 20 or 30 rays that trace to it, and that gives us a lot of confidence that the point in space where that single pixel lies is accurate. Now, photogrammetry isn't perfect. It isn't an end-all, be-all, but this is, like Jeffrey said, one of our most requested services and one of the most common things that you do with a drone system. But because all views in photogrammetry are from the top down, photogrammetry only sees the topmost surface. So if you have a highly forested area and you want to make a model of something that's on the ground, what you're going to get is just the top of the trees. So photogrammetry is best suited to low vegetation environments, urban environments, industrial sites, or places where there isn't a lot of obscuring environment. But photogrammetry provides us with maps, models, and meshes, and they can be extremely accurate. And talking about accuracy is definitely one of the most common questions we get about our drone program. How accurate can you actually make it? And that is sort of a difficult question to answer. But accuracy in drones all has to do with your ground sampling distance. Ground sampling distance is basically the distance between 2 pixels in real-world dimensions. And you can adjust that ground sampling distance by the elevation where you fly your camera. If you have a camera that's high up in the air, every pixel will represent a large area. If the drone's close to the ground, every pixel may represent a very small area. And that all turns into basic resolution. So on the right here, we have a picture where you really can't tell what's going on. You can maybe see that there are some vehicles, maybe you see a rock, but it's difficult to pick out the detail. On the left, with a 2.5 centimeter ground sampling distance, you can really see some of those details. You can see stickers on these tractors. You can see a barrel. You can see much more detail than you normally would at a 10 centimeter ground sampling distance. So one of the things we do at Parsons is we do flight planning beforehand, and we look at what we need to get. How accurate do we need to get? How small can our ground sampling distance be? And we do all that planning before we fly so that we get a high quality result. Now when we do fly, there's basically two different kinds of data collection. You can take nadir images, which are basically straight top-down images, or we've kind of got a solution for if you have some things that are sort of obscured. If you need to get a better 3D model, you can take oblique images and also patch those together, and they will help you model better. That works good for if you have something like a bridge, or you have something else that would obscure. You can take an oblique image or around a building, for example, and that will help you model it better. And once you do process into a model, you have some different outputs. What we're showing here are what are called key points. A key point is a point that our software ties together that it sees in multiple images. You start out by making all these key points, and then you fill those points in to get what's called a densified point cloud. The points in between key points are interpolated, but they're still accurate because of the sheer volume of key points that you have. Once you have these key points, and you can see a densified point cloud is basically a picture, you can turn those points into triangles. You get what's called a 3D textured mesh. And this is one of the late stages in the outputs, and it's actual 3D model that you can manipulate, turn around, look underneath, look on top of, and it shows you what you've got with great accuracy. So once we take all these photos, how do you get a map? If you're taking photos from straight down, one of the things you have is you get distortion from your camera lens. The edges of the photo tend to be stretched while the center is not so much. So the software we use takes all these photos and stitches them together and rectifies the images so that the distance between any pixel is true to life. And you get what's called an orthomosaic. This is an orthomosaic that was taken, and you can see that all the distances are accurate as they're plotted on this map. Now, what does an orthomosaic look like? What can you gather from an orthomosaic? What we have here is we have a picture of some current satellite imagery at that same site that I was talking about in Utah. This is a feature that is actually very important, but with current satellite technology, you just can't tell what you're looking at. Once we flew this area and processed into an orthomosaic, this is the image we got. And you can see there's an obvious depression here. This happens to be a mound where there were buried chemical munitions, and that mound has collapsed. And that's the kind of information that you would really like to know before you send personnel out to a site. You know, if they were to step on this and it were to collapse further, it could be a real, risky situation. But an orthomosaic really gives you a lot more detail so that you can make decisions better and plan. Again, this is our current satellite imagery. And if we look again at the orthomosaic, you can actually see a metal sign here. You can see an animal burrow in the ground. These are all things that can help you make better decisions. So what do we do once we have these maps and models? Well, because they're accurate in true distances, we can use them to make measurements of areas, of volumes, of surfaces, and we can use that data to make decisions. As an example of measuring volumes, we have here a trench and some mounds from that same site in Utah. And remember, this is a site with chemical warfare material. And if we want to know if there's enough dirt here to fill in this trench, we can make measurements. We can measure this trench, and we get a fill volume. You can see it's about 1,100 cubic meters. We can measure these two mounds, and those are cut volumes. They add up to about 1,200 cubic meters. And overall, we see that there's about the same amount of material in these mounds as there is in the trench, or needs to go into that trench. But what do you do when you don't have great data to begin with? A lot of these trenches ended up being filled with vegetation. They looked like this or like this. And if you remember, photogrammetry only gives us the topmost surface. So if we were to model this, we would get the top of this vegetation. So we did a little bit of a study on this. We wanted to find an innovative solution so that we could accurately measure these pits and trenches. And so we measured the volume that was being mapped in vegetation in one of these trenches. We flew this twice. We flew it once with vegetation in it, and then we went back out, cleared the vegetation out of two different trenches, and made a comparison to see if we could find a method that would accurately measure these trenches. What we came up with was basically to treat these trenches like a bowl. If you imagine a bowl and fill it with marbles, those marbles representing the vegetation, you have, when you make measurements using photogrammetry, it measures from the top down. But you get glimpses of the bottom of that trench in between the vegetation. If we take those glimpses and turn it into a bottom surface, then what we're able to do with the software is actually measure from that bottom surface that we create and measure up. If we know then the volume of that vegetation, we can compare it to a flat surface over the top, and then we know how much space that vegetation takes up. So we did some calculations. We measured about 34 cubic meters of brush in a total space of 114 cubic meters. So about 25% of the volume of this trench was vegetation. If we just left that vegetation in there, it could make a significant difference on the volumes that we're estimating. So we did it again, and after we removed that brush from the trench and measured it, we compared our measurements, and we came up with an error of about 3.2% on one and 0.6% on one. So we were able to very accurately measure the volume of that vegetation so that we could take it out, so when we made our final measurements, they would be accurate. And this is just one example of an innovative solution that Parsons has come up with. We sometimes see challenges, and we have to find ways to solve them. Now, another question that we get asked quite often is, do these drones actually save us any money? And in the case of this drone survey that we did at this chemical warfare material site, yes, it saved us quite a bit of money, we estimate. Because of the nature of that site, if we were to go out and do a land-based survey, we estimated that we would need 10 field personnel and 6 weeks of surveying to survey those. In addition, we need on-site medical monitoring, air monitoring. We'd need a contamination reduction zone. We'd need enhanced PPE, respirators. All of that is quite costly. Not to mention that sending our land-based crew out into these pits and trenches represents a significant risk to their safety. So the solution we came up with this drone survey, we actually used one small team with a pilot, a visual observer, and safety oversight. It took us 7 days to collect the data. Because we weren't actually going out into any of the impacted areas, we did not require air monitoring or medical support. There was no contamination reduction zone required because we never went out into contaminated areas. And that resulted in a significant reduction in our safety risk, schedule, and cost. As you can see, we estimated about $320,000 to do a land-based survey, and our actual cost was just over $24,000. So photogrammetry is just the beginning of what we do with our drone workflow data. Many deliverables can be imported into other software, even CAD software, and manipulated to provide even more value. And Jeffrey's going to tell us some of the ways that we've been able to use our drone data at Parsons in innovative ways.
Cool, thanks, Rob. So in the next slide, we're going to look at a model, what's what we call reality modeling. And so what you see in here is originally we had a set of old plans from the owner, and they needed to design they had to redo the roadway, and they wanted to do a few different kinds of design conceptual ideas to see what would work out best. So in order to do that, we needed to make an accurate model of the existing conditions. So with the plans that we had been given, they were hand-drawn from the early 70s. We found consistent errors in the roadway profiles and alignments, and we couldn't be sure that what was being drawn was what we were drawing from 2D plans into 3D models was going to reflect actual site conditions. So what we did in that case is we built up a model, went out with the drone, flew the area, gathered the point cloud, and then with that data, we overlaid the two of them together, and we were able to look and find where all the different kinds of road components went and ensure that our model was accurate with real-world conditions. Another example that we have is with this tunnel shown in this picture next. So this tunnel slopes down underneath into the river, and in order to figure out draw out the actual roadway profile of this, we needed a way to confirm what we were actually seeing in the plans was accurate. So we looked at we took the point cloud and we added it onto the model that we had, and after doing some quick comparisons, we were able to go in and adjust the roadway profile. As you can see on the left, the point cloud matches pretty closely with the roadway. However, on the right, the roadway is too high. So what we ended up having to do was adjust the profile to match the existing conditions. All right, so other different kinds of applications. So in this case, this was on a river-based project where the engineers were trying to determine whether or not a sheet pile could be driven in right near the edge of the bank to put what we call a finger. So basically, sheet pile with a rock in the middle for our crane to drive onto to erect girders across the bridge. In order to do this, engineers wanted to figure out how close the finger would actually be and whether or not this design option was feasible, because it was a cheaper alternative than building a trestle across. With photogrammetry, we were able to model out the finger in our CAD software and then import it in with our point cloud together to get a better view. So if you look on the next image, photogrammetry has a different, you can be able to get different kinds of viewpoints. You can rotate, drag, look around, drag the model around to get the best viewpoint. However, oftentimes what the engineers are actually looking for is just a simple 2D plan. So as you can see in this image, we did section cuts across to look for how close the finger was actually going to be towards the edge of the river. And what they determined in this case was that building a trestle was actually the better option. So by flying a drone, so we set up ground control points, flew the drone, got the real world measurements, put everything into our CAD software, visualized it, and found that the other option was more feasible. And this was all done in around a day and a half turnaround time, versus having to schedule a survey to go out, measure the area, and then let us know the answer a few days later. where our engineers could make that decision. This was a lot faster of an option. And what you'll notice with photogrammetry is that closer to the edge of that riverbank, so closer to the right side, you'll see after the edge of the riverbank, you see little distortions here and there. And what that is because, like Rob was saying, photogrammetry is taking like pixels and combining them together. And so when you have water that's constantly moving and it's a very homogeneous surface, what you end up getting is the computer isn't able to compute where these 2D points are in a 3D space, and you end up having various features like water that's flying 30 feet up into the air. So with photogrammetry, you have to understand the limitations in order to put it into its best use case. One thing to know in photogrammetry is that accuracy is defined in many different ways. And at Parsons, we follow American Society of Photogrammetry and Remote Sensing's best practices, and we have certified photogrammetrists on our team in order to verify any of the products if that's required by our clients. So different kinds of UAS activities. So as you can see in this photo, sometimes we like having fun as well. There's a little man mounted on that drone, so we took this photo drone with another drone. However, let's get down to the real work. So let's look at some site progress documentation. So this is something we do on one of our projects weekly, where we go and we fly, do changeover time monthly, where we fly the drone over the same area. We're able to put it onto our GIS software and compare what has changed over the past month, and creating as-builts. With as-builts, we're looking at where, obviously, sometimes we do field adjustments, and the end result is your plans don't follow exactly what's on what was drawn originally. So we're able to verify our work plan, create as-builts, identify any conflicts before we go off and draw and work in the area. And then tracking quantities. For tracking quantities, all of these different applications, we're doing the same kind of drone flight. It's still photogrammetry. It's still whether or not you fly one day to the next, it's still the same thing. So we go off and for any of these deliverables, we're doing the same flight path. So tracking quantities, our engineers take this data, they're able to go verify quantities are billed by subcontractors. So for example, how much striping is put on the ground. In this particular case, we don't need ground control points because we're using the relatively accuracy of the map, which is pretty close within a few tenths of a foot. So being able to go through rough measurements across an area and tell someone that in that work week they've placed 2,000 linear feet of curb. It's very easy to see when you have drone imagery like this. So it saves time, saves money, and you have proven results that you can send over to other people to show exactly what you had measured. So drones overall gives you great application for being able to see the different viewpoints, be able to capture what you need to be able to share off with your clients. Oftentimes, project managers or those on the office end will need to see what's going on in the field, and UAS provide a great resource for even just capturing the most simple photos. In this next sample, what we're looking at is a client was building a site and needed a very fast, needed a topographical relief map delivered to them as soon as possible. Once Parsons got word, it took less than 48 hours for them to plan the mission, go out, coordinate with local authorities, fly the area, process the data, and deliver the map. Parsons has gotten photogrammetry solutions down to a T, so for simple projects where it's just needing 1 or 2 deliverables, Parsons is able to deliver that very rapidly. Right, so another application of UAS is documentation. Oftentimes we go off and we either design different roadways or we have different results that we need to capture before and after photos for our clients. With UAS, just a simple camera mounted on our drone, we can go off and take these photos that can be saved for documentation, for media, for marketing purposes. Parsons has also used UAS for environmental monitoring purposes. Everything ranged from looking at plant health, looking at NDVI, to revegetation status. Oftentimes we know projects, you have to have a certain amount of revegetation before the project is considered complete. Parsons has done some work with unexploded ordnance using manned aircraft, detecting different kinds of contaminants, looking for oil stains on the water, looking for leaks in different areas. Also using it for erosion control, again, looking at changeover time, looking at how an area could have been impacted based on where soil and debris are flowing to. Here's a quick sample of a field that we've monitored over the past few months. In October of 2019, that field was burned. As you can see in that upper left-hand photo, you can even see the tracks of where the fire apparatus was driving through the area while they were putting out the fire. Over the winter months, you can see the progress developed very slowly, but as soon as summertime hit, everything came back up to normal. So this is just a quick visual oversight of just using raw photos processed into a map. Other different kind of projects we've done plenty of inspection-based projects, including roadway hazard identification with different traffic incident management groups, doing roadway safety assessments, videotaping the roadway, the actual conditions, getting a sample video of what's going on along the corridor, doing site conditions analysis, identifying different areas, cracks and pavement areas that need repair, looking at transmission lines, doing safety engineering analysis, looking at bridge components, crane booms. Basically, looking at hard to reach, hard to access areas can be done with a drone very rapidly. One of the current projects that Parsons has been working on is looking at transmission lines using both photogrammetry as well as high-resolution photos to identify areas of vegetation that are at risk, being able to identify what happens when a power line goes out, looking at what areas need to be monitored more carefully by power line companies. So now we've shown different kinds of various applications and use cases that Parsons has used UAS for. These are things that Parsons is already doing. So we want to talk a little about sustainability, strategy and sustainability. Basically, these are projects that we looked at are all very commonly used across the board, not only at Parsons but different other groups as well. I want to get to that next side of UAS innovation, looking at partnerships, discussing with different groups, and figuring out the best ways to proceed with the latest technology is the best way to go, because each group has their own expertise. At Parsons, we have a variety of them, but sometimes reaching out to others and working with them can get you onto the next level of results that you may need. So let's look at some of the research and development activities that Parsons has done. So Parsons has worked with different groups on swarming technology, on different kinds of sensor fusion, on using machine learning, artificial intelligence to do different things such as tracking objects, predicting trajectory of different objects, using magnetometers mounted on our UAS to look for unexploded ordnance, doing multi and hyperspectral data analysis, looking for things that are hard to find, and doing the edge processing side of things. So instead of taking a long time trying to process this data, being able to process it rapidly. And then looking at LiDAR and synthetic aperture radars, as we just mentioned earlier, photogrammetry is one of the cheapest solutions you can do to be able to create this kind of map. But sometimes you need LiDAR or synthetic aperture radar in order to capture those more fine details underneath the forest or the shrubs. We're looking at different kinds of ways to do confined space inspection with different groups that have a manned aircraft capable of doing that. And also looking at the operational end, so for different kinds of waivers from the Federal Aviation Administration on operations over people. One project I want to look a little bit more into is using thermal imaging. So if you go to the next slide, thank you. So over here you can see Parsons has been working on different kinds of using thermal for looking for objects or unexploded ordnance on the ground. As you can see, Parsons oftentimes runs test platforms with available technology before we go out and spend a heavy investment on a new drone. So in this case, you can see on the next slide we have a setup that looks very home built. We have Inspire One platform with a FlareView Pro with a video transmitter for that thermal camera, with a flight controller, Pixhawk flight controller, with GPS mounted on top to provide the GPS metadata for a unmanned aircraft, as well as a little strobe light on the top of the drone so that we were able to fly at night with one of our Parsons waivers from the FAA. And the results? Well, so what we found is that we're able to get some results from, this is a feasible option for us to explore further with using unmanned aircraft for looking for different kinds of industry standard objects, ISOs, on the surface of an area. We're able to not only be able to use our ground control points to figure out exactly where different objects are, and also be able to spot these different features so a team on the ground can go through and investigate the area further. So as Rob was mentioning earlier about ground sampling distance with UAS, it's the same thing with both thermal and for RGB, so the normal imagery from your normal cameras. Over here, you're seeing with the current setup, we have a 9mm lens, which gives us a wider area but less resolution. So we have found that in order to proceed further and be able to fly at higher altitudes with basically fly at higher altitude and be able to have slightly shorter mapping times, running a camera with a more narrow field of view will be more effective for our research. So on to the future of UAS. So remember at the beginning we said the unmanned aircraft, the drone itself is just a drone. It's just a transportation device. What it carries is the sensors is what is most important in this case. So the size, weight, and power of these sensors that's what's important for what the capabilities of the UAS with things like heavier components like synthetic aperture radar, for example, right now require larger drones. And also we have smaller drones that we use for a variety of other different purposes. But looking at all these different kinds of technology solutions, they'll develop over time. Of course, people are curious on the next big steps on where UAS are going, right? So right now what we've looked at is everything that's all within the realm of the current Part 107 operations, with the exception of doing those night operations. In the future, we're looking at FAA's urban air mobility, being able to do the last mile to package delivery, which many of you have heard about. Looking at remote ID to be able to go on, fly beyond visual line of sight, be able to track all these different drones that will be flying the airspace in the future. Well, all of this comes down to understanding where the technology is headed, where it's going, so that we can make our investments the most worthwhile. So Rob's going to speak a little bit on the Parsons approach and what we've done in order to get to where we are today.
Yeah, so if you have a project where you think you might need drone capabilities, we encourage you to contact us. At Parsons, we're able to help you select and understand the deliverables that you need. We're honest and realistic about our capabilities. We're able to analyze multiple options and provide confidence in our results. Like Jeffrey mentioned earlier, we're not just any drone outfit. We adhere to the standards of the American Society for Photogrammetry and Remote Sensing. We invest, communicate, and understand the technology. And if you have any questions about whether Parsons can help you out on a project, maybe you don't even know what you need, go ahead and give us a shout out. We have an email specifically set up to answer your questions. That's drones@parsons.com. And with that, we'll take any questions you might have.
Thanks, Robert and Jeffrey. So any questions anyone might have, you can submit them in the Q&A section of your WebEx, and we'll read them to the presenters. One question for you guys, about how long does it take between an inquiry for a project and when you guys can actually deploy and present the final deliverables to a client?
That's a great question. Thanks, Tim. So it largely depends on what the final deliverable, what the final product is, and what kind of area we're operating. So in terms of doing a flight operation, to start with, Parsons goes and looks at the airspace that we're trying to fly in. If it's in a more complex airspace with different coordination with different kinds of agencies, obviously that might take longer. Once we've identified that, looking at the final deliverables, final outcomes, how big of an area, for example, for a mapping project, how big of an area are we talking? What are the accuracy requirements for that? Obviously, if you want higher accuracy, you need to fly lower, fly slower, go around, set up different kinds of ground control in order to be able to verify your accuracy, and all of this takes time. But depending on what kind of project it is, we can better, if there are more details on it, we can better give a timeline once we have that information. Overall, for example, recently we had flown a part of a highway in Nevada for a group. That took less than a week of turnaround time before we were asked to fly, and we were out there flying the next week.
Another question, where are you guys based out of primarily? I mean, is there one state or kind of a region of the U.S. or abroad that most of the pilots are based in?
So currently we have pilots in both the United States and in Canada, and we're all spread out across the country. So today Robert is speaking from he's speaking from Utah, and I am speaking from Sterling, Colorado. Different groups, we have groups all over, and we have groups in Denver, in Huntsville, in New Jersey, in Washington State, in Texas. Basically, everyone's spread out in different parts of the country. In Indiana, we're all spread out all over the place.
Perfect. Another question from Cody Areno. Do you have the capability to perform a 360-degree panoramic obstruction survey in support of site survey initiatives?
The answer to that is yes as well. If you're talking like photograph or like just 360 photograph, yes, we are able to take 360 photographs and be able to stitch that together. I am not familiar with the surveying component of using those 360 photos, but using it to get a quick site overview and understand different aspects that are happening on site, that is certainly very doable.
Cody says thanks. And next from Diane Hoding. Have you ever performed any wildlife habitat surveys?
Well, I have not. I don't believe within Parsons we have yet. But, I certainly know of many people who have done so before, including different state agencies and Parks and Wildlife departments and across the state.
Jeffrey, if I can chime in and add a little bit to that. The capability is there. I've even heard of projects where people have been able to take drones out to a forest and do mapping. They use both near infrared and visible light surveys, and they do tree surveys. And combining that data, they're able to count the different species of trees in an area. So the capability is there to do lots of different wildlife and habitat surveys.
Any other questions to be submitted in the Q&A or the chat? All right. Well, if not, Robert, would you like to take us to the final slide? I wanted to thank everyone for joining us today. Remind you that the next webinar will be on September 9th from Randy Palachek on environmental modeling and statistical analysis. We hope you'll join us for that. And also a reminder to the audience that this presentation has been approved for CEU credits, so please reach out to Scott Hartzall if you need any documentation for that. And with that, again, thank all of you for joining. Thanks to our presenters today, and hope you all have a great day.
Thank you everyone for joining. That concludes your call. Please disconnect your lines and have a very good day.